this particular class we are going to discuss about the equation of tangent to the circle S is equal to 0 at a point x1 y1. Okay, all of you pay attention here. So first of all, let us say this is the circle equation. S is equal to 0. Here there is a point x1 y1 on the circle. Here there is another point x2 y2 on the same circle. S is equals to 0. Then what is the equation of this chord? x1 y1 is one point on the circle, x2 y2 is another point on the circle. What about the equation of the chord? This chord equation, no doubt 2 points are there. With the help of these 2 points we can find out the line equation. Y minus y1 is equal to slope into x minus x1, right? So that idea, definitely you will get the equation of a chord. That chord equation you will get in this way: S1 plus S2 is equals to S12. The equation of that chord you will get S1 plus S2 is equal to S12. You can take the circle equation as like this: x square plus y square is equal to a square. A simple equation we can take, or you can take the general form of the equation of a circle. Any case, the equation of chord is S1 plus S2 is equal to S12 you will get. Okay. So how? I'll try to discuss. What is S1? First of all, tell me. S1 means you know x x1 plus y y1 minus a square, that is S1. What is S2? X x2 plus y y2 minus a square is equals to. But what is S12? S12 is nothing but x1 x2 plus y1 y2 minus a square. I hope so everyone is familiar with the notation. That is the reason last class I discussed about the notations. Those notations plays a key role in the entire circles and conic section, parabola, ellipse and hyperbola, right? So this is S1, this is S2, and this one is nothing but S12. S1 plus S2 is equal to S12. Or suppose a line equation, this line is satisfied by 2 points. One line satisfied by both the points on the line means that line represents the equation of this particular line. Okay. So that's why I am substituting x1 y1 here. Substitute x1 y1 here. What happens? S1. Yes or no? Or x1 y1 point I am substituting here in place of x x1, in place of y y1. That's why S11. Here if you substitute, what happens? S12 is equal to, nothing is there, S12 only, right? Now S12 S12 cancel, because x1 y1 is a point on the circle. X1 y1 is a point on the circle means definitely this value is equal to 0 or not. So that's why x1 y1 satisfying this equation. X1 y1 satisfying this equation, right? Next we will check in the similar way x2 y2 also satisfies the equation or not. Come on, substitute x2 y2. Here I am substituting x2 into x1 plus y2 into y1 minus a square. Here also I am substituting x2 square, right, plus y2 square minus a square is equals to, same here, nothing is there to substitute, xy is not there to substitute, x1 x2 plus y1 y2 minus a square. This is nothing but, don't say s21, either x1 into x2 or x2 into x1, same only. That's why this is also s12 plus this is s22 is equals to S12. Here also satisfying, because S12 gets cancelled At the same time, x2, y2 is a point on the circle. When this point lie on the circle, we can write s22 is equal to 0. So that's why this point satisfies this line equation. This point also satisfies this line equation. That's why we can say the equation of this chord. The equation of this chord is S1 plus S2 is equal to S12. So x1 y1 and x2 y2 are 2 points. The same chord equation you will get in parabola, ellipse, hyperbola also. Right, x1 y1 and x2 y2 are 2 points on the circle S is equal to 0. Then the equation of the chord is given by S1 plus S2 is equal to S12. Now one more important point we are going to discuss. The equation of tangent to the circle S is equal to 0 at a point x1 y1. Right, pay attention here. Now the chord AB is becoming a tangent at A. That means what happens? The chord AB becomes a tangent at A. That means the point B is approaching to A. Whenever the point B approaches to A, what happens? The chord becomes tangent at A. So now I am asking, what is the equation of this tangent? The point B x2 y2 is coinciding with x1 y1. Whenever the point x2 y2 is coinciding with x1 y1, the chord is now becoming a tangent at x1 y1. Let us say this point is now P x1 y1. Right? So this point P x1 y1. Now what happens? x2 y2 गायब हो गया. x2 y2 गायब होके क्या हो गया? x2 y2 हो गया x1 y1. So that's why now wherever x2 y2 is there, that means wherever 2 is there, 2 का जगह में 1 लिखना है. Right? So write down s1 plus s1 is equal to s11. 2 गायब हो गया. 2 गायब होने के बाद 2 changes as 1. That's why x2 y2 changes as x1 y1. Now in place of x2 I written 1. Now s1 plus s1 is equal to s11. Or x1 y1 is a point on the circle. When x1 y1 is a point on the circle, this s11 becomes 0. That's why 2 times s1 is equal to 0. Therefore we are getting s1 is equal to 0 is the equation of tangent to the circle S is equal to 0 at a point x1 y1. To the circle S is equal to 0 at a point x1 y1, a tangent is drawn. The equation of this tangent, this line equation is S1 is equal to 0. That means this line equation is given by x1 plus y1 minus a square is equal to 0. This is the equation of tangent to the circle S is equal to 0 at a point x1 y1. So whatever the circle equation you are taking, for the circle S is equal to 0 at a point x1 y1, to the circle S is equal to 0 at a point x1 y1, a tangent is drawn. This tangent equation is given by S1 is equal to 0. What is S1? X1 plus y1 minus a square is equal to 0. So that is the equation of tangent to the circle S is equal to 0 at a point x1 y1. So whenever we discuss the derivatives, there we will discuss actually what is the geometrical meaning of differentiation at a point. That I will discuss in our limits and derivatives chapter. We will discuss the proof also, but at present try to remember. This is the circle. To this circle at a point x1 y1, at a point x1 y1, a tangent is drawn to this circle. Let us say the circle equation is x square plus y square is equal to a square. To the circle at a point x1 y1, a tangent is drawn. Slope of this tangent slope is nothing but dy by dx at a point p x1 y1. That means this curve differentiate at a point x1 y1, then what we will get? This line slope we will get. Once again, differentiate the given curve. This is the given curve. We are differentiating at a point p x1 y1. Then the value whatever you will get, that is nothing but this line slope. Come on, you know the differentiation of this. X square differentiation is 2x plus y square differentiation is 2y into dy by dx is equals to constant differentiation 0. X square differentiation 2x plus y square differentiation is 2y into dy by dx is equals to 0. From this I can write dy by dx is equals to minus x by y. So dy by dx we got minus x by y. But differentiation at a point px1 y1 is nothing but minus x1 divided by y1. Array this line slope we got minus x1 by y1. And the point you know x1 y1, slope you know, point also we know. Then what is the line equation? The line equation is y minus y1 is equals to slope minus x1 by y1 into x minus x1. Sir, here x1 y1 is a point on the circle. Yes, x1 y1 is a point on the circle. Then I can write x1 square plus y1 square is equal to a square. Keep it aside. We will think about that. Okay, right. This simplification y1 minus y1 square is equal to minus x1 plus x1 square. Therefore, we are getting x1 plus y1 is equals to x1 square plus y1 square. Now, in place of x1 square plus y1 square, what we can write? A square. So, it becomes x1 plus y1 minus a square is equals to 0. This is nothing but the equation of the tangent to the circle at a point x1 y1. Same s1 is equal to 0. Earlier we discussed, same we got s1 is equal to 0. Now I discussed with the help of the differentiation, the other method, we got the same answer, right? So one more method we will discuss. Yes, come on. So the other way of doing the same question. Actually proof is not required. All these ideas are required for objective exam. That particular point is required. Proof is not required because these are not there in the subjective exams, right? Okay. Now the other way I am discussing. Can you tell me what is the center of this circle? Circle equation is x square plus y square is equal to a square. The circle is center is 0, 0. Radius is equals to a. Okay, same x1 y1 is a point on the circle, so we will get x1 square plus y1 square is equal to a square. This is the condition you will get. Now what happens? From this point a line is drawn perpendicularly onto this. Now these two are perpendicular. Can you tell me what is the slope of this line? This line slope is equal to y1 divided by x1. Then automatically slope of this line is equal to minus x1 by y1. Earlier differentiating at a point x1 y1 also slope we got the same only. So now slope is there, point x1 y1 is there. We can find out tangent equation or not, right? So that is the discussion regarding the equation of tangent. The equation of tangent to the circle S is equals to 0 at a point Px1 y1. To the circle S is equal to 0 at a point Px1 y1, a tangent is drawn. The equation of the tangent is given by S1 is equals to 0. Right? Now, another question here is, this is the circle. Let us say the circle equation is x square plus y square is equal to a square. Now this is the line. Let us say the line equation is y is equal to mx plus c. Now from center onto the line, the perpendicular distance is equals to d and radius is equals to r. If r value is less than d, then what happens? The line does not intersect the circle. But when the line touches the circle, the line touches the circle under the condition r must be equal to d. If r is equals to d, the line touches the circle. At the same time, when the value of r, this is center, perpendicular distance is equals to d and radius is equals to r. In this case, r value is more than d. Here r is equals to d, whereas here r is less than d. R less than d means the line does not touch the circle. R is equal to d means line touches the circle, whereas r greater than d, the line intersect the circle at two distinct points. But what about the length of this chord? Length of the chord is given by r square minus d square multiply with 2. Because by Pythagoras theorem, this becomes the root of r square minus d square. Because it is a middle point, multiply with 2, you will get the length of the chord. This chord length is given by 2 into root over r square minus d square. Now my question is, the line y is equal to mx plus c. The line y is equal to mx plus c touches the circle. The line touches the circle. X square plus y square is equals to r square. So circle center is equal to 0, 0. Radius must be equal to perpendicular distance. Line touches the circle, then what is the condition? So circle equation, no doubt x square plus y square is equal to a square. From center onto this line, the perpendicular distance. You know the perpendicular distance, modulus of m into 0 minus 0 plus c divided by square root of m square plus minus 1 whole square. That is the perpendicular distance. That perpendicular distance must be equal to radius. Therefore, we are getting c is equals to plus or minus a into root over 1 plus m square. That means the line y is equal to mx plus c touches the circle x square plus y square is equal to a square. Then we can write the condition as c square is equal to a square into 1 plus m square. That is the condition. C square is equal to a square into 1 plus m square. Now the c value substitute there. Y is equals to mx plus or minus a into root of 1 plus m square. So this is the equation of the tangent in slope form. The line y is equal to mx plus c touches the circle. The line y is equal to mx plus c touches the circle. X square plus y square is equal to a square. Then the condition is c square is equal to a square into 1 plus m square. Whereas the equation of tangent in slope form is y is equal to mx plus or minus a into root of 1 plus m square. Okay. Here a simple point. Sir, here the center is 0, 0. So we got the tangent equation like this. What we got the tangent equation? The tangent equation we got it as y minus 0 is equals to m into x minus 0 plus or minus a into root of 1 plus m square. That is the equation of the tangent in slope form we got, right? So center 0 comma 0, radius is equal to a. Sir, suppose I am taking the circle equation as not this simple circle. Every time you are taking simple circle only. Now I am taking the general form of the equation of a circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0. If this is the circle, then what is the equation of the tangent in slope form, sir? Nothing. The equation of tangent in slope form is y plus f is equals to m into x plus g plus or minus r into root over 1 plus m square. Easy to remember. Y plus f. Sir, y plus f क्यों? Because the reason is this circle center is minus g comma minus f. What is the radius? Radius is equal to square root of g square plus f square minus c is the radius, right? So that's why in place of 0 we have to write minus f. In place of 0 we have to write minus g. That is the reason x minus of minus g. So we got y plus f is equal to m into x plus g plus or minus r into root of 1 plus m square, where r is equal to radius of the circle, that is g square plus f square minus c under root. Okay, so that is the equation of tangent in slope form. So another important point I am going to discuss here about director circle. So what is a director circle? All of you observe here. This is a circle. Let us take the circle equation as simple equation. X square plus y square is equal to a square, right? So from a point x1 y1, tangent drawn. This is one tangent. Same point x1 y1, another tangent is also possible. This is another tangent. From a point p x1 y1, these are the two tangents drawn to the circle. If these two tangents intersect at right angles, that means angle between these two tangents is equals to 90 degrees, then where this point lie? From an external point, two tangents can be drawn to the circle. Those two tangents are intersecting at 90 degrees. Those two tangents are intersecting at 90 degrees. Then locus of this particular point, where that point lie? That point lie on a circle. This circle is called a director circle. Definitely anywhere on this circle you can take a point. Suppose you take a point on this circle, draw tangents. Angle between those two tangents is equal to 90 degrees. I am going to show, this circle is concentric with this circle. For this big circle and this small circle, center is the same only. So how? We will discuss that point here. So the locus of all these points, that means this particular point, locus lie on a circle. That circle equation I am going to find out. Okay, right? So as you know, this one is y is equals to mx plus or minus a into root of 1 plus m square. The equation of tangent in slope form is this one. Y is equal to mx plus or minus a into root of 1 plus m square. But this line is passing through a point x1 y1 or not? Substitute there. What we will get? y1 is equals to mx1 plus or minus a into root of 1 plus m square. Check here. y1 minus mx1 whole square is equals to a square into 1 plus m square. Now further simplification, y1 square plus m square into x1 square minus 2 times m into x1 y1 is equal to a square plus a square m square. Right? What about the simplification? That further simplification we can do it like this: m square into x1 square minus a square minus 2m into x1 y1 plus y1 square minus a square is equal to 0. What you are observing? This is a quadratic equation in m. It is a quadratic equation in m. It has two values. One value is equal to m1, the other value is m2. Sir, why two values? M has two values because this line and this is another line. So one line slope is equal to m1, second line slope is equal to m2. But these two lines, what is saying in the question? Those two tangents are perpendicular. That means m1 into m2 is equal to y1 square minus a square divided by x1 square minus a square. Product of the slopes is equal to minus 1. Because both the tangents are perpendicular. Product of the slopes must be equal to minus 1. Now from this you will get x1 square plus y1 square is equals to 2a square. At this point x1 y1 locus we have to find out. That's why x square plus y square is equals to 2a square. This is the equation of director circle. That means anywhere you can take a point on the circle. This is the director circle we are saying. You can take a point on this circle, draw tangents. Angle between those two tangents is equal to 90 degrees only. So anywhere you can take a point on this circle, draw tangents. Angle between these two tangents is equals to 90 degrees. The locus of point of intersection of perpendicular tangents. The locus of point of intersection of perpendicular tangents lie on a circle. That circle is called director circle. The equation of director circle to the circle x square plus y square is equal to a square is x square plus y square is equal to 2a square, which is concentric with this circle, and radius is root 2 times. This radius multiply with root 2, you will get the radius of this circle, because x square plus y square is equal to root 2a whole square. Okay, so that is the discussion regarding this particular idea here, director circle and that particular concept. Now you can see here the same discussion. This is the circle. Let us say the circle equation is x square plus y square is equal to a square. From an external point, yes, we can draw two tangents. This is one tangent and this is another tangent. These are the two tangents drawn from an external point. Let us say this point is P, x1, y1. Now this point I am taking point of contact as A and this point of contact as B. Now the center of the circle is equal to 0, 0. No doubt these two are perpendicular. Agree or not? Perpendicular. Now join center. So this is say CP. So this angle is equals to theta by 2. Angle between two tangents is equals to theta. Then this becomes theta by 2 and this is the radius of the circle, or I hope so everyone know this is the length of the tangent PB. And PB is the length of the tangent. Earlier we discussed the length of the tangent is equal to root over S11, right? So that's why we can write from the diagram tan theta by 2 is equals to R divided by root over S11. Tan theta by 2 is equals to R by root over S11. That is another important results which will be helpful for us. Okay. So this is the idea regarding this particular concept. Now we can have another discussion here. The circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 is a circle. What is the intercept made by the circle on x-axis? You see, What is the meaning for that? So this is the circle. I am asking the intercept made by the circle on x-axis. This length or a circle center is equal to minus g comma minus f, and from this a line is drawn perpendicularly. This length I can say it as minus f. Simply we can say modulus of f. This height is equal to modulus of f. At the same time, this is the radius of the circle, that is square root of g square plus f square minus c. Now can you tell me what about this distance? This distance is nothing but square root of g square minus c. So whatever this one is also same. So that's why the length of the intercept made by the circle on x-axis is equals to 2 into root of g square minus c. The intercept made by the circle on x-axis is equal to 2 into root over g square minus c. Similarly, the intercept made by the circle on y-axis is same way we can prove 2 into root of f square minus c. Now what happens? Suppose the circle touches the x-axis, or a circle touches the x-axis means now this length is गायब हो गया. So this length is becoming 0. Then what happens? G square minus c is equal to 0. Therefore g square is equal to c. The intercept made by the circle on x-axis is equals to 2 into square root of g square minus c. The intercept made by the circle on y-axis is equal to 2 into root of f square minus c. If the circle touches x-axis, then g square is equal to c. Similarly, if the circle touches y-axis, then we will get f square is equal to c. Or if the circle touches both the axes, when the circle touches both the axes, what happens? There is no x-intercept and there is no y-intercept. If the circle touches both the axes, then we will get the condition g square is equal to f square is equal to c. Right? So now, what happens? Circle touches both the axes. Circle touches both the axes. Whenever circle touches both the axes, center must be in the form of r comma r. Center must be in the form of r comma r, because this is also the radius, this is also the radius, but this distance is r, this height is also r, the center is r comma r only. So the equation of the circle is x minus r whole square plus y minus r whole square is equal to r square. If this radius, that means r comma r, here also possible one circle, here also possible. Here you are taking means r comma minus r. Here we are taking means minus r comma minus r. Here we are taking means minus r comma r we have to take. Whereas here r comma minus r. So that's why we can write the circle equation as x plus r minus r whole square plus y plus r minus r whole square is equals to r square. So that we can write x square plus y square plus r minus 2rx plus r minus 2ry plus r square is equal to 0, because here we will get plus r square, here we will get plus r square, 1 r square cancel. This is the circle equation. If you know the radius of circle is r and touches both the axes, means here also possible, here also possible, here also possible, here also possible. 4 circles are possible. So that's why these are the equations of the circles. Okay. So these are the few ideas related to the circle ideas. Next class we are going to discuss a few more questions. Okay. Bye.